Okay, so we have three types of the page replacement algorithm. So we are going to start with the first one. Okay, so a simple and obvious page replacement strategy is the first in first out, or the FIFO. Okay, so as new pages are brought in, they are added to the tail of the queue, and the page at the head of the queue is the next victim. So the first page, or the first value that comes in, would be the first value to set up. Okay, so in the following example here, okay, so with the reference string, okay, so the page requests here would be 20, okay, and considering 3 frames, okay, so 3 frames, that means 3 pages can be in the memory at a time per hour per process. So initially, from the algorithms, okay, so it should be an empty frame. Everything should be an empty frame. Okay, so we first allocate 7. Now this is considering 3 frames. Allocate 7. Next is allocate 0. Next is allocate 1. Okay, so from the algorithm, okay, so when we allocated 1 here, okay, so there is no free frame anymore, and therefore we have to select the victim. Okay, so with first in first out, the first value that comes in would be the first value to set out. So in that case, that's 7. So replacing 7, so plotting 2, 0, 1. All right, so next we need to allocate 0. 0 is already allocated. So if the string is already allocated, or the page is already allocated, you don't have to reallocate it. You just have to move to the next. All right, so we need to allocate 3 here. Okay, so allocate 3, we already have replaced 7 here. Okay, so the next value, or the next page to be replaced, would be 0, because among these values, or among these pages here, 0 is the oldest, right? So we need to replace it with 3 and then copy 1. Okay, next we need to reallocate 0. So between these 3 pages here, 2, 3, 1, 1 is the oldest, or 1 would be the first who came in. So we need to replace it with 0. That's how it works. Okay, so although FIFO is simple and easy, it is not always optimal or even efficient. All right, so we need to allocate 4 here. Allocating 4, so page to be replaced would be 2. 2 is the first page to come. Right, so that would be 430. Next is to allocate 2. Next to replace would be 3. Right, next is to allocate 3. Next to replace would be 0. Okay, and then allocate 0. So we need to replace 4. 4 came in first. Okay, so allocate 0 on the place of 4, and then 2 and 3. 3 is already allocated, so you don't have to reallocate it. 2 is already allocated. Now we need to allocate 1. Right, so between these 3 pages here, 2 was the first page to come. So we need to replace it with 1. So resulting 2, 0, 1, 3. All right, and then for 2, allocating 2, okay, so we need to replace 3 here and then place 2 there. All right, so allocate 0 and 1. 0 and 1 is allocated. Next is to allocate 7. So who's our victim? The victim would be 0. Okay, so allocating 0, or allocating 7, sorry, in place of 0, you've got 7, 1, 2. Next to allocate 0, the victim would be 1, so plot 0. And finally, allocating 1, our victim is 2, replacing it with 1. All right, so in this example, with 20 page requests, so this resulted to 15 page faults. Okay, so how do you come up with 15 page faults? So you have to count the number of occupied frames here. So there would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So that would be 15 page faults. All right, now as what I'm saying, although FIFO is simple and easy, it is not always optimal or even efficient. Okay, now we can consider this Okay, so consider this reference string here: 1, 2, 3, 4, 1, 2, 5, 1, 2, 3, 4, 5. Right? So if we are going to plot this, okay, so using first in, first out, okay, so what would happen would be adding more frames can cause more page faults. So take note that from the diagram that we have earlier, as we increases the number of frames, the number of page faults should be decreasing, but not in the case of this given here, right? So what actually happens here, adding more frames can cause more page faults. So we call it Belady's anomaly. All right? So this is what I'm saying. Okay? So with the consideration of this reference string here, if you try it, okay, you started with 1 frame, that would give you 12. 2 frames, that would give you 12. That's fine. All right. So 3 frame, that decreases to 9. That's good. But increasing the number of frame, we're expecting it to be the same or lower down, right? But the thing is, when we use 3 frames, we get 9 page faults. But when we use 4 frames, we get 10, right? So this is what you call Belady's anomaly. Okay? So an interesting effect that can occur with FIFO is this Belady's anomaly, in which increasing the number of frames available can actually increase the number of page faults that occur. All right? So that's Belady's